welcome to the Actual Astronomy Podcast, episode number 39. In this episode, we're going to talk about the Summer Triangle and the Perseid Meteor shower. How are you this afternoon, Shane?
I am pretty good. How about yourself?
I'm doing really, really well. I know I'm kind of, I've been texting you a pile of photos.
Yeah.
I didn't mean to overwhelm your Sunday brunch or sleep in or whatever with, oh my God, another photo from Chris. But I think you were looking for some photos maybe to put up on our YouTube feed. So I wanted to make sure I gave you lots, or to send tweets out or whatever.
Yeah. I like to, if possible, I like to send some photos out over Twitter that relate to things we're talking about on the podcast. So if anybody wants a visual, they can go there and check it out.
I have refrained from doing because I get up to observe. Now, I get up this morning, even though I was pretty sure it wasn't going to be observing conditions, I still get up and check because I'm trying to do a pretty good run on Mars and Venus while they're both very high in the sky. And this is going to go on here for at least another 4 weeks. And I was gonna send you a text at 4:30.
Well, you can. My phone's on Do Not Disturb at that time.
Okay, good stuff. Good stuff. So anyway, I won't do that anyway. I think that's generally in poor taste, but it really is a really good season for doing astronomy, and as such, and the university wanted me to. I'm actually teaching my astronomy class, and one of the things we're going to do this week is the Summer Triangle and talk about the Perseid meteor shower. So in an effort to kind of kill two birds with one stone, I really hope you don't mind me doing this. I kind of sent you the text this morning. I said, can we please do it on these so that I don't have to create more and more material every week for a whole slew of different topics. And then what I'll do is I'll turn these two into part of my presentation this week. So thank you for indulging me.
Oh yeah, I think it's great. I'm excited to do it.
Yeah, so the Summer Triangle, Shane, and the other, in fact, a good portion of the reason why I wanted to do the Summer Triangle is that most people don't realize that about 40% of the astronomers that get lost in space get lost in the Summer Triangle. That's an accurate statistic, isn't it?
Yeah, it's been validated many times.
I think it was funny because I think I messaged or emailed or texted you this as a bit of a joke this week, and you were like, I think your spouse had made an almost identical comment.
She did, yeah.
Yeah,
I was showing her the Summer Triangle, and she asked, "Is that where the astronomers get lost?" And
and then like 3 days later, you get this text from me, and you're like, "Man, I'm getting it from all sides." You know?
Exactly. Yeah.
That's pretty amazing. But the great part about the Summer Triangle is actually this is where astronomers get found. Like this is really where you find your bearings in the nighttime sky. So it's kind of like the opposite of getting lost in space. This is where we kind of get found in space. And so what is the Summer Triangle? Maybe we'll start at that point.
Well, it's three of the brightest stars in the summer sky that form a fairly easy to identify triangle, which is also a big chunk of the sky.
It's huge.
And then once you identify it, it really helps you navigate to a lot of other constellations in the summer sky. So it's easy to find once you become aware of it, and then it's a really good navigational aid after that.
And it's not a constellation, though, is it?
No. It would be what we call an asterism, which can be a little confusing. I think the best example of asterism, or maybe not the best example, but a common one that I think some people can wrap their heads around. There's Ursa Major, which is the bear, or the constellation of a bear. However, most people know a part of that constellation as the Big Dipper. Now, the Big Dipper is the asterism. The constellation is Ursa Major, the bear. So usually the asterisms form some combination of really bright stars and some sort of recognizable object like a dipper or the Sagittarius teapot, and in what we're talking about today, the summer triangle.
And I think that's a perfect way of just you often you say, like, I make some notes, but you said this way better than the way I have it in my notes. I just want to make that comment clear for people. Is Shane's really talking off the top of his head maybe a little bit more than I am, and that was really awesome. The only thing that I will just add to that is that the asterisms are really like the star patterns, and the constellations are the regions. Maybe is the
that's a good way to put it.
Yeah, kind of just to sort of condense it down a little bit. But yeah, I really like the way that you put that. So one thing I looked at today, I'm interested in the history of things a little bit. So I kind of was thinking, okay, well, how far back does this thing go? And then I saw that H.A. Rey. Now, H.A. Do you know who H.A. Rey was?
I do not.
So, yeah, I think you're just like about maybe a couple years younger than me, like literally. And when I was young, and I know because my wife is about the same period younger than me, and she's not as familiar with H.A. Rey. H.A. Rey was huge, but I think I was sort of at the tail end of the H.A. Rey phenomena. And he was like maybe the Barney of a time, and he wrote the Curious George books.
Oh, really?
Yes, he wrote the Curious George books, and that's what he's most known for. But H.A. Rey was also an amateur astronomer, and he wrote a book, and I forget the name of the book. I should have it here. I actually have the book. It's downstairs in my library. My library isn't upstairs anymore. But he wrote a book on the constellations. So if you Google H.A. Rey constellation book, and he in many ways is responsible for revolutionizing the way that amateur astronomers, people that actually go out and do stargazing, interpret the star patterns. Now, he didn't, they may not be as widely accepted, but just his general transformation of those star patterns, he made them look perhaps a little bit more like what they're supposed to, or in the absence of that, figures that are a little bit more easy to wrap your head around. And so I think that prior to that, the constellations were still very much esoteric or exclusive to those mythological features, with some very inconsistent lines drawn. Whereas after H.A. Rey, the lines have become more consistent and even more basic. But he's the one that really kind of started that transformational process. So he had written about that, as had Patrick Moore, the famous British astronomer back in the 50s. But going back even further, in the early 1800s, Bode, perhaps in Western cultures, is the first that connected the three stars of Deneb, Vega, and Altair. But he didn't write about them. And Bode, of course, is famous as the early 1800s astronomer for Bode's Nebula, which are M81 and M82, as I think you'll probably recall, Shane.
Mm-hmm. Yep.
So he was an early astronomer who was making some discoveries. But that's only just in the Western culture. We only go back maybe a couple hundred years, say maybe just over 200 years. But Chinese stargazers, they've been connecting these stars for over 2.5 centuries. So goes back pretty far. They were using these as sort of celestial storytelling features. And in fact, and if I'm correct in what I've read about Chinese astronomy and astrology, the really neat part that's quite different about the Chinese astronomy and astrology, apart from some of the more Western astronomy that we're familiar with, is that they would more frequently use a larger pattern and then break it down into smaller patterns or constellations, which I think is actually an easier way to learn the night sky. And that's exactly what we're doing with the summer triangle.
Huh. So they sort of larger regions to make it easier to navigate and find various things in the sky. Is that the purpose for it?
Yeah. So, for example, and now I'm not going to try to go in and tell the stories from a Chinese perspective. I just don't understand them as well as I probably ought to. But for example, we have Cygnus, Lyra, and Altair that form the primary three constellations in the Summer Triangle, and the three bright stars, the brightest stars in each of those, and they form this giant triangle. But in the middle, we have Vulpecula and Sagitta, Delphinus to one side, and then just below Scutum. So, and then in amongst those, we have our deep sky objects like Albireo, which is a nice double star. We have M57, which is the Ring Nebula. And by finding that larger feature, and depending on the equipment one has, you can gradually drill down. And I think that this harkens back to what the early Chinese astronomers were trying to do, or successfully doing. They were taking a large piece of sky that is much easier to find and easier to navigate, and then breaking it down into manageable parts, or more focused parts. And that's kind of what we're doing here. We're taking the Summer Triangle and then we're breaking it down into the constituent constellations, and then within those there's some deep sky objects. So we're kind of using that same sort of tried and true technique that goes back for now thousands of years. It's pretty cool.
Yeah, very neat.
So one of the great things about the Summer Triangle is that the Milky Way cuts right through it. So even from the city, if you can find it, you can point a telescope or binoculars at it. And if your city's not too big and bright, like ours isn't that big a city, you can point your binoculars up there and see, maybe some of the star clouds that you can't see with the unaided eye. Did you ever do that from your driveway or backyard? I think your backyard's darker than mine.
Yeah, I have panned through there with binoculars, and even occasionally a telescope. I'll just go through there, and it's a noticeable increase in the density of the stars when you're panning through that Milky Way region.
Mm-hmm. And I go ahead.
Oh, I was just going to say, I kind of like panning around in that Cygnus area. Albireo might be one of my most frequented objects in the sky. I look at it quite regularly. And then from there, I just kind of work my way up the cross. And there's so many little clusters to look at in that area. It's a fun part of the sky.
So when is it best to view the Summer Triangle? I always feel like the Summer Triangle is a little bit of a misnomer, because you think when summer rolls around that's when it's going to be at its best. But when is it really at its best? It's kind of a little bit later in the year, I think, isn't it?
Well, later, or I'd even say maybe earlier. Like for me, what I hate to observe is things that are right overhead or near zenith.
Okay.
And right now, depending, I guess, when you're out, but like if I'm out around 10 or 11 o'clock, the Summer Triangle is directly overhead, and that's just a difficult place to observe in the sky.
Yeah, you're right, because if you're dealing with the Dobsonian telescopes, you're dealing with something called Dobson's hole, or it is just very difficult to look straight up overhead. You're right.
Yeah, but later in the year, or like I said, even a little bit earlier in the year,
as it's rising,
you can get some decent views. Or later in the year, it'll be starting to set a little bit, and it won't be overhead.
Yeah, kind of sort of building on that, and I guess maybe what I was hinting towards is that I do find kind of as we get into the latter part of August and into the autumn time frame, it's really nicely situated in the sort of high in the western sky, but you can still see the whole thing. And then it just kind of seems to sit there for weeks on end as it gets darker earlier each night. It seems like it's getting darker at about the same rate each night that the constellations would have shifted to the east. So you go out at 8 o'clock one night and you can look up and see the Summer Triangle there. Now, let's say it just got dark at 8 o'clock, or dark enough that you go and look. You come out the next night, well, it's going to be that dark at about 3 or 4 minutes to 8, but those constellations will be virtually in the same spot, plus or minus a few arc minutes. Then, of course, once we kind of get so far along, they seem to sort of speed up. Of course, they don't, but just kind of the way things work.
Yeah. No, that's a great point. Later in the summer, due to the darkness, would be a much better time. And if you really are under some dark skies, there is some outstanding stuff in that region to see.
So what are some of the big things that maybe you'd like to go and take a look at up in the Summer Triangle region. When you go to do observing from a dark side, Shane.
The North American Nebula is probably at the top of the list. That's not an easy nebula to observe visually. You do need really dark skies. And when we go down to Grasslands National Park, we are fortunate to have some of the darkest skies available. And, we've talked about it before on previous podcasts, how, there's a lot of different names for these objects. And I feel like a lot of the objects don't live up to the name. However, the North American Nebula does. Like when you see that, it's like, oh yeah, there's kind of Canada and the US, and you see Florida and the Gulf, and it really makes sense that's North America there.
And right beside it is the Pelican. Right beside the North American is the Pelican Nebula, which doesn't quite look like a pelican through the small telescope.
No. So yeah, I love that. That coat hanger cluster. Now you don't need a dark sky for that. You can actually see that from within the city.
It's not. That's also an asterism. We talked about asterisms earlier. It's not. Those stars, I don't believe, are associated. There is a cluster in there somewhere, but the coat hanger cluster itself, which is index catalog, I think 399 or Colander 399 is the official catalog after a per colander from the early 1900s.
Yeah. And that's another arrangement of stars that it looks like its name. It does look like a coat hanger, although I think it's upside down probably at that point in the year.
I think you're right. Yeah, through the instruments, you're going to see it as upside down. That is, now it's not technically a set of associated stars, but it's still an object, and it's an object that's really cool to look at. So I think that makes it something. And that was first observed in around 964 AD by Persian astronomer Al-Sufi.
That's interesting.
So it goes way back, and it just shows, like, I can kind of see it as a fuzzy spot, and I can kind of make out the stars knowing where to look. But considering he was somebody, and I wear glasses, but he was somebody who probably wouldn't have had glasses, or unlikely, and he was observing, of course, without any advanced knowledge of telescopes, or that the object was even there. He discovered it. So
wow, that's incredible.
Yeah, pretty fascinating what some people like him and Tycho Brahe and others have been able to do without an instrument.
Yeah. One other object I'll mention up there is the Ring Nebula, associated within Lyra. It looks like a donut in the sky, and it's a nebula that really shows well in just about any type of telescope. The larger aperture ones make it look a lot nicer or easier to see kind of the donut effect of it. But that's a common object that when we're doing public outreach and people are looking through our telescopes, I'll often show them the ring at some point in the evening.
Now, what is the Ring Nebula exactly?
That is a planetary nebula, if I'm not mistaken.
Yeah. It's a planetary.
Yeah, so that star, I don't know the history in terms of timing, but it went supernova at some point.
Not quite supernova, I don't think.
No. Oh, okay.
No, those ones they kind of just puff up and give up their outer atmosphere, and then that drifts off into space, and it forms. That's why you get the ring. Now, I think, and we're doing this kind of live. We don't do any edits or anything like that, and we've got Veil supernova remnant right beside this, and it's the Veil that was caused by a giant supernova that went off. Maybe even around the same time.
Yeah. And yeah, what's kind of neat about the ring is that it seems to be, I wouldn't say like light pollution proof, but it's more resilient to
very bright,
light pollution. Yeah, it is very bright. And yeah, just a neat object to show folks. But probably the showpiece in that area is the Veil. Would you agree with that?
Yeah, from a dark sky, I mean the Veil supernova remnant is quite amazing. I think you really got to get to the medium sized telescope, something bigger than about a 4 inch or larger. Like I've observed it with my and sketched it with my 60. But when I've had my 60 on it, I've tried to show it to people. Even from really good sites, it's tough.
Yeah, yeah.
You
It's
really,
huge too, which
yeah,
is
it's
why the
large.
60
Yeah.
millimeter, it's nice to look at through a smaller aperture like that because you get
Yep.
a much wider field of view. But I've looked at it through a 20-inch Dobsonian, and oh my gosh, it is almost photographic. You see the wispiness and a lot of that structure and detail within it. The
Hmm.
only problem is you have to pan an awful lot to see the whole nebula through such a large telescope because your field of view is the size of a pinhead.
Yeah. I think one of the best views and one of the reasons why I bought a 4 inch or 5 inch telescope is I think the around the 5 inch is sort of the best size for getting most or a significant portion of the veil in the field of view, and you get the right sizing with the right brightness. Once you go much smaller, it gets dim really fast. Once you go much larger, the field of view starts, in my opinion, to get too small too quick. So there is a bit of a nice size. But with an 8 inch Dobsonian, like many people would have, that's a nice instrument to look at it with, I think.
Oh, absolutely. I used to have an 8-inch Dobsonian, and I looked at the Veil Nebula many times, and it was outstanding. I
Hmm.
really enjoyed those views. What
And
up?
then
What? Oh, sorry. I was
I
just
was
going to
gonna.
ask you what objects do you like up there, or do we
Well,
key on them?
you mentioned Alberio, and then there's Epsilon Lyra. Which one's the double double? They call it the double double because it's like two sets of 2 stars or something.
Yeah, up in Lyra, that's Epsilon A and B, I think they call it.
Okay,
Yeah.
all right, and it's commonly referred to as the double double, right?
Yeah, yeah, because in one field of view, it starts off as like if you're lower magnification, you'll see two stars that are both white and essentially the same magnitude. If you apply more magnification, you'll find out that both of those stars are in fact double stars, and the companions are also identical. So you have like two sets of twins essentially that they both look like each other. It's a really neat object, or I guess two objects to observe.
Yeah. Now, recently, I was talking to another observer, and they were saying that the double double goes well with the donut of the ring
Oh
nebula.
yes, yes. All Canadians will understand that
so,
joke.
so here in Canada, double double is sort of common vernacular for how many people who like lots of cream and sugar order their coffee at a certain establishment.
Yes, yes. It
which
that. Oh, go ahead.
which I don't care for as much personally. I'm more of a black coffee fan myself.
I'm with you on that one.
Yeah.
The double double in Lyra is sometimes a good test of seeing. If you can't split those, seeing isn't that good.
Mm.
But and this takes experience, and that's probably why when you're out and you can observe the double double from within a city, always take a quick look at it so you get familiar with how it looks under different magnifications, and then you can use that as a little bit of a gauge to see how good the seeing is.
Hmm. Hmm. Cool.
Yeah.
Um, my favorite object, though, one of my favorite objects there, I do like the Veil. I like the North American. The North American is a star from a region right beside Deneb that we were talking about, but kind of between and sort of closer to Deneb and running down, not quite as far to the Veil, is the Northern Coal Sack, which is a dark nebula complex. And that's pretty neat. And then just above or just northwest is this really neat dark nebula, and it's called Le Gentil 3. And the reason why I like that nebula, it's dark, so it's one of the things that kind of makes it look like the Milky Way is split in two, which I think is really neat. Most people who go out and see the Milky Way will recognize it as this giant band of clouds, which is broken in places by something. But then, with a little bit of knowledge, you can understand that these are some dark nebula, and these dark nebula are the building blocks for some of the later star-forming regions in the life cycle of stars. But Le Gentil 3, to me anyway, it often takes on a slightly different cast, and it doesn't show in images. I'm just looking, but I think, to me anyway, it looks almost purplish. And the reason why is that I think it's got some star features and like thin stars sort of spread over it. And for whatever reason, that must be like blue giants, or maybe it's part of the light absorbing of Le Gentil 3. And it does almost have like a purpley, or it's definitely different than the northern coal sack, which is like a dark region. And then also right in the middle of Cygnus, there's a brighter region, which is the Cygnus star cloud, which I like looking at an awful lot. It's quite neat to look at. Right around, I think it's Satyr, which is the middle star running down to Alberio at the end of the cross asterism.
Yeah, very interesting. Would you need very dark skies to see those dark nebula, or moderately dark?
Fairly dark, yeah, sort of definitely on the darker end of the spectrum, but you don't really need any optics to take a look at these. You just you can Google them and see kind of where they are generally, and as long as you can find the Cygnus constellation, which looks like a large cross, you can probably locate those. Binoculars can be fun to kind of sweep, but beyond like a very small, basic, inexpensive, simple pair of binoculars, you don't need any kind of fancy equipment to look at them with. So that's always quite enjoyable.
Right on.
Yeah, cool. So do you have anything else left to add? Oh, the summer triangle points down to the south at this time of year, and the top part, like you said, it's Vega, I think, is pretty close to the zenith, which is the point directly overhead once it gets dark these nights. So even though I know you were saying it can be difficult to look straight up, definitely there are more comfortable times of the year. The fact that Vega is so close to the zenith, at least for us, so if you're in North America or in the northern hemisphere, Vega is going to be pretty close either to the zenith or getting pretty far towards the overhead region. You can kind of trace out the summer triangle pretty good, and then the Milky Way cuts through it and it points south, so you can kind of keep going from there and get to the south. So do you have anything else to add about the summer triangle or that region of sky?
No, nothing else. That was a good discussion.
Well, why don't we move along to talk about the Perseid meteor shower? How does that sound, Shane?
Yeah.
When did you first watch or start watching, or what's your first recollection of seeing the Perseid meteor shower?
Well, yeah, I can't remember. I would have been, I think, 18 or 19, and was just out with some friends in the evening, and I can't even remember if somebody else looked up or I looked up first, and was just like, whoa, 2 or 3 shooting stars appeared, and then kept watching, and it just seemed like nonstop meteors. And at the time, I didn't understand that meteor showers were, repeatable, that they happen, at certain points in the year. And I thought we just happened to luck out, and, we're out on a rare night when one of these things happen. And again, not knowing what I really was observing, I think I also was out for, a considerably good show due to the rate of how many I was seeing. And I wasn't under dark skies. Like, I was just outside of Regina, which is, a city of, I don't know what we're at now, 250,000 or something like that.
Yeah.
So, there's considerable light pollution, but it was a fantastic night.
Cool.
Yeah. How about you? When did you first see it?
I think I was 14, either 14 or 15, anyway, around that age. And I think we'd sort of tried to see them before, but of course I'm from the Maritimes, and it's traditionally it can be not great weather at that time of year from time to time. Although I think August is the best month to visit the Maritimes. If people are looking for a trip, it's a great place to go. For astronomy, maybe a little bit lower down your list, just because sometimes we can get a lot of cloud that will come in at night. And so I was actually out camping, although that's a bit of a stretch. We were like literally camping in a friend's backyard at their summer home, and like cottage, like farmhouse cottage kind of deal. And my mother had called, and I was like, whoa, like what's going on? Like, why is she calling? Because I, was somebody who was sort of out on my own quite a bit as a young child, and involved in a lot of activities that took me away from home. And typically my parents got pretty used to me, weren't really, trying to keep tabs on me too close, even at 14. And so they called and they were like, hey, you've got, like, it's going to be clear tonight. You've got to go out and see these, because they knew I was interested in astronomy. So I went out, and my friends really weren't that into it. And so they kind of went to bed, and I was getting out every once in a while and looking up. And I wasn't really sure what I saw. The Milky Way at first, and I thought maybe that was it. And then I think I did see some shooting stars. Then when I finally got home, my mom kind of grilled me on it, and so that's when I kind of realized that it was sort of the shooting stars that I was seeing, and I'd seen maybe 3 or 4 of them only, because I didn't like sit out all night, and nobody else wanted to stay up with me, and I was still relatively young, so I wasn't really going to do that by myself. And anyway, so I did see quite a few that night. And then it was after that, I was like, okay, well, like, that's what it is. And I really, at that point, like around, like I said, around 13 or 14, I started kind of putting a lot of this astronomy business together in my head and saying, okay, well, like, these are shooting stars, and, this is kind of what they are, and reading about them and kind of getting interested in doing astronomy as an activity that I was more interested in than most of the other kids, clearly. So.
Yeah, that's awesome.
So what is and I always feel like a lot more about meteors than I do, because you actually collect, and this isn't in my notes or anything, but you collect actual meteorites, I think.
Yeah, I've got a small collection of meteorites. The ones that or what kind of got me into meteorite collecting, well, there's a few things. One is it's just cool that you have a rock that came from somewhere out in space.
Mm-hmm.
That's really neat. Some of these rocks or meteorites are exceptionally old, and depending what you get, some of the meteorites may contain some of what's believed to be some of the original building blocks of the solar system. So exceptionally old stuff. But what's really cool is when there's impacts on other planets, namely Mars and Venus, like the rocky planets, or our moon even, there's debris that, when there's an impact, there's a massive release of energy. So there's debris from the planet that will be kicked up into the atmosphere, and some of it actually leaves the gravitational pull of that planet and can end up on Earth. So I have 3 meteorites. Well, I have a number of meteorites, but 3 that I really, I guess, are kind of my showpieces in the collection are one is from Venus, one is from Mars, and one is from the moon.
Wow,
And
you should put them on your book that you just bought.
Yeah, I probably should.
Take a photo of that and tweet it out. That's pretty cool.
Okay, yeah, I can do that.
There you go. More work for you, just what you need.
More work, yep. They're fairly insignificant. Like they don't look, well, they're not very big. And they've like through various analysis, I guess the scientists are able to determine points of origin. But anyway, yeah, I do have some meteorites, and they're kind of fun.
Yeah. So I guess, well, these probably didn't come from a meteor shower, though, because the meteor showers are a little bit different. And I think with those meteorites that you have, they would have produced like a pretty significant fireball. Is that correct? That's fairly correct.
Yeah, for sure. One that I have is the Buzzard Coulee meteorite, which is from our home province. And I don't remember the year that one landed, but that was a substantial event. Like when that meteorite came through, it came through at night, and it turned night into day across a couple of provinces.
I think it was 2007 or 2008, because it was before I moved out here. So.
Yes. And that one deposited a lot of meteorites all over the place, and people went out collecting, and then was able to acquire one.
Yeah, we know some of those people quite well. So yeah, it's very, very, very cool. So when you're seeing a meteor come in, or maybe one of these ones like you have, what's the difference between that and a meteor shower? Is that a good question? I just kind of made that question up, sort of based on my notes.
So the difference between like a meteorite, like that lands on the Earth?
Yeah, or just like a random meteor. Like, so you look up and you see a
Ah,
meteor just on some random night, or like what's the difference between that and a night where you're going to go up because it's the Perseid meteor shower, for example, like that are happening this week.
right. Well, I would say probably the biggest difference is the amount of meteors that you'll see. You can see, a meteor on any given night, but if you're out and there's not a meteor shower happening, if you see a meteor, it's likely the only one you'll see.
Mm-hmm.
Whereas with a meteor shower, you will see many meteorites over the entire night, and probably about 2 to 4 weeks prior to the apex and 2 to 4 weeks after the apex of the meteor shower.
Okay.
So
Yeah.
it's quite a heavy period of activity.
And I think those ones that you just see like one-offs, like on any given night, like we go out to dark site. Like when I was out a few weeks ago at a really dark site, probably saw like 5 or 6 over the course of 2 or 3 hours. Those are just called, I think, sporadics or something like that.
Oh, okay. Yep. Yep.
I think that's what people call it. But the Perseids, they originate from Comet Swift-Tuttle. I think most of these meteor showers, they actually originate from comets one way or another. And this one passed in the vicinity of Earth in 1992. But it won't be back. I think it comes back like every 133 years or something like that. Anyway, you can do the math. The next pass of Comet Swift-Tuttle is 2126.
You and I won't be seeing that one.
Well, I plan to be here, but we can make alternate plans. So. Yeah, that's a long time. We've got over 100 years left to wait on that one. I thought I saw a Comet Swift-Tuttle, but maybe I'm wrong. I was just really getting into astronomy then. I was still just in school, but I think maybe I did see. That might have been one of the first comets I saw. And why are they called the Perseids?
Well, any meteor shower has a name associated with a constellation, and that's because most of the meteors that you'll see during that time radiate from that point of the sky, near that constellation. So in this case, if you're out, you'll see most of these meteors originating from Perseus in the sky.
Okay. Cool. And Perseus is, at this time of year, it's going to be rising in the north east, correct? Yes.
Correct. And, an easy way to find Perseus is to find Cassiopeia, the W star, or the W constellation, I should say. That's pretty prominent. Most people can identify it.
Yeah.
If you see Cassiopeia, you kind of look down and to the left, and that'll be the region of Perseus.
Yeah. Cool. Yeah, that's a pretty good way to find it, actually. Yeah, a lot of people will already know where Cassiopeia is. If not, that is, I would say, in the top 5 or 6 constellations that people, or patterns that people could know. First, typically, it's the Big Dipper and Little Dipper, followed by like Orion and Cassiopeia. I would say those are probably your top 4.
Yeah, I think you're right.
So most of these particles, they're in orbit, and I was reading this just this morning when I was kind of making the notes up. They've been in orbit around the sun for over 1,000 years.
Wow.
I was like, whoa. So unless we intersect like a stream, so every time the comet goes around the sun, we intersect with a stream, and this comet has been going around the sun for thousands of years. But many of the streams that we intersect are from pretty old orbits, or they're part of that comet, which is perhaps billions of years old. So just to think, I was thinking about this. It's pretty wild to think about. So you look up and you see, because what does a meteor look like when it comes in from the Perseid? Maybe we should describe it for people. Like, what do you see when you see a Perseid meteor?
Well, it's essentially a shooting star. Like, you will see a streak of light across the sky. They will vary, though, in brightness and I guess maybe how far they travel. Most of them will just be streaks of light.
And they're pretty fast, these Perseids.
Yeah, quite fast.
Just like a moment in time kind of thing. Blink and you miss it almost.
Yeah, like it's not, you would never mistake it for an airplane or a satellite or anything else. It's definitely the fastest thing up there.
Yeah.
And some of them may be exceptionally bright. And some of them you may even see a little bit of a tail kind of, or tail maybe isn't the right word, but like you almost see like their path left behind
I think
in the
it's
sky
like,
for a little bit of time.
so I've looked at and I don't have any of that written down here, but there's like either a smoke trail or an ionization trail, or maybe it's both. Do you know anything about that? I've seen that before, where you look and you see the meteor, and it's almost like you get like that after image in your eye, but it's not, because they're not quite that bright. And then you take your binoculars and you look, and you can actually see the trail.
Yeah, I've heard it described as an ionization trail, and it
Is that what it
sometimes
is?
to me it even looks greenish.
Yeah, it kind of
Yeah, yeah.
glows. It
A
glows.
little bit, yeah.
Yeah.
And it doesn't stay for very long. Like if you
No,
actually get one of those, it you
less than
would
a
time
minute.
its life in seconds. Yeah.
Yeah, less than a minute. Yeah, for sure. Yeah, those are really neat. And apparently, this is one thing I was reading about this morning as well, is that there was a filament of dust ejected off the comet Swift-Tuttle back in 1865, and that can actually give another peak a day or so before,
Oh,
which
really?
I hadn't heard about before this. So, but our peak activity, really, maybe what it comes down to is people should go out between about now, like the 9th and the 14th. So, depending on your particular location, you should be able to go out after midnight. I think is usually about the best time to go out and look.
Yeah, yeah. The darker the better. And unfortunately, the moon is going to be up, I think, during this entire or during the apex here of the Perseids, which is unfortunate, but it doesn't mean you can't see them. There will still be lots of meteors to observe.
Yeah, and I think, well, the moon is getting pretty far across now. Like it's near Venus, so it's really in almost like the twilight time. And I think for the most part, people are going to be out, maybe going out um, around midnight or so for a couple hours is probably your best bet to see lots. And I've certainly seen lots around then, but I think the typical sage advice is for people to get up early in the morning, go out and look. But of course, the moon's going to be up at that time. You might still see some, but probably around midnight, I think this time for this particular shower, that's probably your best bet to see the most meteors from the Perseids this year.
Yeah, yeah, I think so.
So, and how many an hour? Like, I know, like they say, like around 60 or more per hour, but it's weird. Like on off years when we're not supposed to get one of the big streams, like I've gone out and hardly seen any more than like in a random night. In a random night, you and I are observing. I kind of feel like we might see at a really dark site maybe a meteor or two an hour, kind of on average. Is that about
Yeah,
right?
yeah,
Something like
yeah,
that. On a like around this time of year when the Perseids are kicking up.
yeah, for sure.
Um, and I've actually gone out on Perseid Meteor nights and not really seen any more than that.
Yeah.
But
That,
once, sorry, go ahead.
I was just going to say that's the kind of the disappointing or the frustrating thing with meteor showers is there's all sorts of predictions that are put out there in terms of how many you might be able to see per hour.
Yeah,
But the accuracy of those, I don't know what it is, but I don't think it's very high. Like a meteor
no,
shower is almost something you just have to get out there and go see what it's like, because you might be rewarded with one where there's a couple hundred per hour, which is a very high rate.
yeah,
However, you might also be out there when you're not seeing, anywhere near that.
and I did, I guess not have as good a luck. Some years I saw, I think 12 or 13 an hour, and then I was at a high mountaintop location about 7 years ago, and at the Mount Kobau Star Party, and it was the night I arrived, and I was beat from a really, really too long a drive during the day and big trip up the mountain, and we're at about like 7,000 feet or whatever it is up there. And so yeah, I was just hanging out, and we had like a sudden burst, and I ended up seeing like that whole like more than 100 in an hour kind of thing. In fact, I think I saw probably 200 or 300 in an hour, maybe more. And yeah, I've never seen that before. I've never seen it since. It was pretty phenomenal. I've seen some outbursts. Saw an outburst in whenever it was 2003 or whatever, big Lyrid event was. But yeah, maybe a couple times I've seen a pile of them come in. Like I've had nights where I've seen like 5 or 6 come in over, a few minutes, and then nothing again for a long time. But that night we saw just meteor after meteor. It was just like, and we were sitting around a circle facing outwards from each other, and multiple people are seeing multiple meteors at the same instant. It was just ridiculous how many we saw. So almost like if you didn't know what they were, it would be maybe a little bit scary, but that these things are the size of a grain of sand, and they're just ending their thousands and perhaps billions of years of existence in the solar system very spectacularly as we see them come in.
Yeah, that's a good point, that they are very small. And the bright ones that we were talking about just a couple minutes ago that leave sort of that greeny ionization tail, those are about 10 millimeters in diameter. So that's
really that big, eh? Okay, so like a
Yeah.
centimeter or a third of an inch or something like that.
Yeah, those will be the brightest ones. Those
Yeah,
will be the
okay.
brightest ones.
Okay.
So these things are exceptionally small, and essentially none of them reach the surface of the
No.
Earth. They all burn up in the atmosphere.
Yeah. You ready for some fun facts?
Let's do it.
I looked up when it was first observed in 3680. I don't know who it was that saw it, but I saw a reference somewhere that it was first observed in 3680.
Wow, that's a long time ago.
Yeah, as probably somebody saw a bit of an outburst, like a couple of ones that we've referenced, and then they made some sort of remark. And John Denver talks about it in his song Rocky Mountain High, about his experience watching, it raining fire in the sky.
Yeah, that's a good way to describe it.
Gotta say, more of a punk rock fan than a John Denver fan myself, so I'm barely familiar with that song. And this was one I've heard of is Catholics referring to it as the Tears of Saint Lawrence. Knowing many Catholics, I have heard them refer to that as being the Tears of Saint Lawrence, which occurs on or about the August 10th anniversary of. And I'm not sure I'm not going to get into St. Lawrence. St. Lawrence to me is a seaway. So more than anything, unfortunately. So I'm not going to try to get into any kind of interpretation of what it means, even with the notes. I don't quite understand. So I'm not going to do that. So how do you see them? Like what you described where it is in the sky, it's in the north east. You said it's right below Cassiopeia. What else? What else do people need to do in order to see the Perseids and have a good time seeing them? What should people do to prepare for that?
Well, a meteor shower is probably the easiest thing you can go out and observe because all you need are your eyeballs. Now, there's some things you can do to make it more comfortable and enjoyable. Number one, plan to be out for a couple of hours. This isn't something where you go have a quick look and say you've observed it. Comet Nemo wise, you could do that with, I suppose. But this is something you should spend some time out and take it all in.
That was sort of my mistake when I was 14. I was like, okay, I got 5 minutes here while I'm outside the tent. Everybody else is getting ready for bed, and then. Did I see one? I don't know. Was that it? Did I see the meteor shower? I don't know. I'll find out later, I guess. No, you need to stay a couple hours.
You do. Yeah, the beauty of a meteor shower is the length of it, I think. So prepare to be out there for a while. So that means get a comfortable chair where you can kind of lounge back and look upwards.
Or an air mattress.
Or an air mattress. Yeah, that's a great one. Some people also bring a sleeping bag so that you can crawl into the sleeping bag, get into your chair, and then observe. Because as you and I have mentioned before, when you're out under a dark sky and the temperatures drop and you're not moving, 10 degrees Celsius could feel like minus 10 Celsius. It doesn't take long for you to get cold. So dress warm, bring a blanket, maybe bring a thermos of hot chocolate or some warm beverage to
non-alcoholic. We should stress that. Is that it's best not to consume alcohol when you're doing any of this astronomy stuff, because it negatively impacts your eye. And when you're under a dark sky, you're using your eye to its greatest capability, and alcohol will reduce your ability to see the faint things and to be able to track on stuff. Like, you just can't quite focus as well. Apparently, I've never really tried having too much alcohol while I've been out doing astronomy. It really just doesn't mix well anyway. You know?
For sure. So really, that's all you need. One other thing I'll mention is red lights. Stick with red lights if you need any
Right.
light at all.
Yes.
If you turn on your cell phone to take a look at your Twitter feed or Instagram, you're going to ruin your dark eye adaptation, which takes up to 30 minutes to get fully adapted. So bring the red lights if you need them. Leave the other ones behind. And if there's any astrophotographers out there, you can get some pretty interesting photos that night too of streaks of light in your frame, because you're going to be doing astrophotography with exposures of probably anywhere from 5 seconds to much longer if you have a tracking mount. Now, for meteor capture, I wouldn't really recommend a tracking mount because your camera will be moving, and if there's a meteor, I think you'll end up with some strange distortion. So just place your camera on a tripod and probably do 5 to 10, well, maybe even 5 to 20-second exposures, and you're going to end up with a whole bunch of streaks of light in your frames that will be the Perseids.
Awesome. That's great advice.
Yeah.
Well, I think we've covered it quite well, unless you have anything else to add. I'm at the end of my notes, but I know sometimes you have more extensive notes than I do.
No, I think, we covered off everything that I would want to talk about with the Perseids. This is the premier meteor shower of the warm weather months. This is the best one that you can see. The best meteor shower in terms of the numbers of meteors that you'll see happens in December. So we'll probably talk about that one in December, but, at least in Canada, it's cold and, it's not the best observing conditions usually at that time of the year.
I've gone out and observed that one a handful of times.
Mm-hmm.
Not as much fun.
No. For sure.
Yeah, it's pretty chilly. All right. Well, thanks so much, Shane. Thanks for joining me today and doing this. And how can people get in touch? Maybe people will go out and take some. It would be really cool. Starting to get enough followers down, enough downloads for sort of well over 3,000 downloads. And it'd be really cool if somebody went out and took a photo of a Perseid and sent that to us. And if they did, how could they get that photo to us?
Well, they could tweet it out and tag us. We are at Actual Astronomy. You could email it to us. We are actualastronomy@gmail.com.
Cool.
If anybody emails us something, we'd give you full credit if we tweet it out. But get out there, observe it, and hopefully some folks can see how many meteors or count how many meteors they see.
And we're just doing this for fun, so I don't think there's any commercial gain at this time.
No.
All right, excellent. Well, thanks so much, Shane, and thanks everybody for listening.
Thanks, Chris.